Welcome, this is Mr. Hyatt, and this flip will be about the idea of molarity, which is the first measurement of concentration that we'll use here in chemistry. Now, when I say concentration, let me move my face here so you can see a little bit better. What is the difference here between these glasses of Kool-Aid? Essentially, we've just added more of the powder through this. Would be what's called a serial dilution. So this has the least amount of the powder, this one has the most, and then there are steps in between. That's the idea behind concentration. How much of the powder, how much of the solid is dissolved into a solution. So, again, let me move so you have room to read it. So molarity is a measure of concentration. The unit is moles per liter. So we're going to need to be able to calculate moles, maybe from grams. And notice the abbreviation here is capital M, not lowercase m. We already have a lowercase m. That's mass. So a 1 molar NaCl solution has 1 mole of NaCl per liter. A 2 molar has 2 moles per liter. So you see how the molarity works. The great thing is this is a fraction bar. Anytime we have a fraction bar, we can use it as a conversion factor, so we can apply stoichiometry to it. Think about when we talked about density leading up to the final exam. Same exact concept. We've got a fraction, so we can use it as a conversion factor. So I've got a couple sample problems that I'm going to show you because I want you to know how I'm going to ask these questions. I want you to know how to attack them. I still strongly encourage you to do the given and need setup like we did last semester. I didn't show that in these slides just to save time. So I hope that doesn't confuse you. So calculate the concentration of a solution that has 1.23 moles of sodium chloride in 1.75 liters of solution. So I've got a number of moles and I've got a volume in liters. That should make this pretty easy. If I get rid of this, we see that 1.23 moles of sodium chloride divided by 1.75 liters gives us 0.7 molar, 0.70 molar. So that's the first style of question. Next up, let me move over here. How many milliliters of 1.8 molar sodium chloride contain 0.865? So this is essentially algebra. We're just using different parts of the equation. So I'm using it as a conversion factor. So I've got my 0.865 moles. So solute might be a new term for you. Solute is something that's dissolved into a liquid. So in the Kool-Aid example, the Kool-Aid was our solute. In this example, sodium chloride or table salt is our solute. So now let me move up and get my face out of the way here. So I take my 0.865 molar and I'm going to use, my 0.865 moles of sodium chloride. I'm going to use my molarity as a conversion factor. Notice I put the 1.8 moles on the bottom, even though our unit is moles per liter. Since it's a fraction, I can flip it. I need the moles to be on bottom to cancel here. So that works. But I'm in liters and the question asks for milliliters, so I need that extra step, that extra conversion factor to get me into milliliters. It's the only active unit, it's the one I need. So that's good. There's an example of using it as a practice problem. As a conversion factor. The version of this presentation, that's the Google Drive version that's on Canvas, this is a link, and you can look through several practice problems if you want to do them and check them. I think that would be a really smart idea. Do a couple, and if they make sense, move on. If they don't, come ask for help. So when you're doing Stoich with molarity, we're going to use these 3 steps, the same steps that we used before break. So we're going to turn the given into moles, whether it's grams or molecules or whatever. We're going to turn it into moles. Then we're going to use the mole ratio from the balanced equation to convert from moles of one thing to moles of another. We did a ton of that before break. So here's a practice problem where you might need to do some Stoich. Calculate the number of grams of hydrogen produced when 89.1 mils of 1.38 molar HCl is reacted with excess zinc. So excess zinc means we have too much of it. The thing that's going to stop the reaction is when we run out of hydrochloric acid. So let me just delete that. And so here's my Stoich. looks kind of similar to the last problem, but of course there are more steps. So I start with my volume, and I'm going to convert it to liters because remember molarity is moles per liter. So once I'm into liters, I need to use my molarity to get into moles of HCl. Then from there, this is stuff we did first semester. Once we're into moles, now we can do our stoic stuff. We can do our mole ratio that comes from the balanced equation. We can do our molar mass conversion to get from moles to grams. And just like before, there are some practice problems on Canvas that will hopefully help. So that's molarity. Hope it makes sense. If you have questions, let me know.